Yeah, hello, dear. Good evening. Very, very good evening, my dear students. How are you all? Once again, मैं आपका राकेश तलरेजा वापस स्वागत करता हूँ इंडिया के largest online learning platform that is Grade Up. Yes, so welcome you all to the India's largest online learning platform and wish you a very good evening, everyone. So, in the previous sessions, of the electromagnetic theory on this startup series on YouTube, we were having the basic discussions about the vector calculus. Okay. Wherein we were trying to understand all the three coordinate systems, that is Cartesian, cylindrical, and spherical. Now, moving forward, as I told, in the startup series, we try to pick up some, important concepts, important topic that will, be useful, very, very useful in exams like GATE or ESE. So I thought of moving towards plane waves now. Okay. And several sessions on uniform plane waves and the wave propagation questions, polarization, and etc. Because if you are especially an electronic student, the most of the important questions from the EMT, let me again tell you, will start from the plane waves. Okay, propagation of plane waves, refraction of plane waves, reflection refraction of plane waves, and then transmission lines, waveguides, antenna. And to understand whole of this, first you have to get yourself very much familiar with the plane waves, the concept of plane waves. Okay, so slowly and gradually we'll first discuss the concept of plane waves, some basic calculation and properties of the waves, and then we will derive the whole of equations of wave and see the questions that can be formed in the exam. So my dear students, as you all know, the whole country and the whole entire world is facing this disease. So let me remind you to wash your hands regularly, stay safe at home, do not leave your homes, follow the lockdown rules, and keep washing your hands regularly by applying the proper Dettol or a soap. Okay. And these are the national contact number of the national control room setup. You can have the numbers on screen. If you have any troubles, any symptoms, you can uh, definitely contact on these contact numbers. And my brief introduction, I'm Rakesh Talreja, and I've secured all India rank 9th in GATE from the electronics and communication engineering, and I've completed my masters from ISC Bangalore. And my major area of expertise are these subjects, from which in the startup YouTube series we are currently studying some important topics of electromagnetic theory. Okay, so with this, once again, a very good evening and welcome to everyone to the Grade Up GATE YouTube channel, and let's proceed with some of the concepts. Okay, so whenever we talk about waves, step by step we'll go. First, we'll try to understand. See, as I've told, we are going to learn about uniform plane waves. Yeah, definitely. To be very honest, dear students, if I tell you, for an electrical student, keeping GATE and ESE in mind, this is not required. Okay, this is especially, but for EC, this is highly important. For electrical, it's not required. Okay. So if your main focus is GATE ESE, then this portion for electrical is not required. Okay. Yes, answer for that question will be n equal to -2, Harsha. Can solve it by the spherical coordinates divergence formula. Very simply solve it by the spherical coordinates divergence formula. Okay. Yeah, fine. So, yeah. Rupak, which specialist, which subject you want to refer to actually? Yeah, Rupak Chaudhary. Yes. So, in general, let's first understand what are plane waves, and then we will talk about the concept of uniform plane waves. Okay. And even before going to plane waves, let me tell you some of the basic classification of waves. Waves, whenever we think about waves, what are waves in general? They are nothing but just means of transporting energy from one point to another. Okay. Transporting energy from one point to another, whether they are transporting through medium or through space. Accordingly, they are classified as electromagnetic or mechanical waves. Okay, so whenever, especially, see, our concern will be on electromagnetic waves. But to begin with, let's have slight basics about waves. Then plane waves. That is what I need to start with today. Plane waves and then uniform plane wave. These are the two key things that we must know. कि actually plane waves होता क्या है and uniform plane waves होता क्या है. Okay, so any electromagnetic wave example, for example, commonly radio signals, the radio waves, okay, the FM waves or the TV signals, okay, even the light rays, even FM waves. What are the radio waves doing? Okay, they are just transmitting the information sent by the transmitter, okay, which is at any particular FM station. A transmitter is based, located, or it is a built. It is trying to transmit the information from the transmitter to the receiver, from the transmitter to the receiver. So waves are just a means of transmitting energy. How they transmit, that is what you have to learn. Okay, when you cover up the whole plane waves and transmission line waveguide section, then you learn how actually the transmission occurs. ठीक है, ये energy क्या है, ये power क्या है, ठीक है, how to measure the power of electromagnetic waves. When we go towards the power of electromagnetic waves, we actually encounter a theorem known as the pointing theorem. Okay, and then we derive a vector known as the pointing vector. So just very briefly, we define waves are a means of transmitting energy, but actually how they are transmitting energy, ठीक है, how much energy, are there any energy losses or not, यही हमें step by step conquer करना है. ठीक है. So for example, before going towards electromagnetic wave, if I just take the case of water waves, which are definitely not electromagnetic waves. Yeah, Rupak, for electromagnetic there are two good books, Sadiku and Haidt. And अगर आपको सबसे सिंपल तरीके से बहुत अच्छा कंटेंट पढ़ना है तो then definitely you can go for the book of Sadiku. It's the best. ठीक है. Haidt, for the beginners, Haidt might be little complicated for the beginners. It's a very good book, but for a beginner level, if I tell, this is the very best book, Sadiku. Everyone, you can note down this book for EMT. It's the very best book for a beginner level and it will make all concepts clear. मतलब beginner नहीं, ऐसा नहीं कि सिर्फ basic है. It has all possible cases explained in a very beautiful manner. So you can go for this textbook for this subject especially. So if I talk about water waves, see, imagine there is a silent water body. There is a stationary water body, silent as of now, and to this water body, I hit a stone. I throw a stone basically. What happens? To the water body, when I hit a stone, what happens? Obviously, you all might have seen that water waves, which will appear to you circular in nature, these water waves are formed, which appear to you circular in nature. Okay. So when I hit a stone onto a stationary water body, water waves are formed. Okay. Now, what is two important points about these water waves? What are two important points about this water wave? Number one. Okay. So let me just highlight this one and let me just highlight this particular circle. It's a very logical question, very observation based question. I hope you must already be knowing this fact. If I just mark these 2 points, say this is a point A and say this is another point B, where will be the intensity of the water wave higher? Can you please comment? Where will the intensity of the water wave be higher? Yeah. Can anyone say at which of these 2 points the intensity of the water wave will be higher? Yes, students. Yes, Zayan, that's correct. The intensity at A will be greater than that at B. Okay, because A is a point which is close to the source. Now this is my source where I have hit the point. Okay. And number 2 point, yes, everyone commenting here, that's nice. Number 2 point. Now, even if I look at the point A, okay, if I discuss about the point A and consider the intensity at 2 times T1 and T2 such that T2 is greater than T1, what will be the value of intensity at the point T1 and at the time T1 and T2? At the time T1 and T2 at the same point. आप एक ही point को continuously observe करो. See, what was the activity? I repeat. To a stationary water body, I have dropped a stone. I have simply dropped a stone. Okay. What will be the effect of that? Water waves are generated. We have compared the intensity at two different points. ठीक है, the point which is closer to the source, the point which is closer to the source will have higher intensity. ठीक है, जितना दूर आप observe करोगे, ठीक है, as far as you go, जितना दूर जाते जाओगे, at some point you will not be able to see the waves also. You will not be able to see the waves also. ठीक है, the further you go, the intensity of the wave will reduce. ठीक है, apart from that, when I compare the intensity of wave at two different times, T1 and T2, such that T2 is greater than T1. मैंने एक ही बार स्टोन हिट किया, जस्ट इमेजिन आई हिट द स्टोन ओनली वंस, वाटर वेव स्टार्टेड, ठीक है, एंड दे विल ऑब्वियसली डिमिनिश आफ्टर सम टाइम, they will obviously diminish after some time unless and until मैं repeatedly stone hit नहीं करूं. Just imagine it as a one time activity. मैंने एक बार stone drop किया, waves generate हुआ कुछ time के लिए, and automatically after some time they will diminish away. They will, you'll again see a stationary water body. So as the time increases, the intensity of each and every point reduces. So intensity at T1 will be greater than T2. T1 will be greater than T2. With time, intensity will reduce. That means what I want to say, and not only for water waves, whatever you derive for electromagnetic wave, मैं पूरा derivation Maxwell law को समझते हुए पूरा derivation consider करने वाला हूं, ठीक है, but before going towards the Maxwell equations, now we are just talking about some logical things, ठीक है, केवल logical बात करते हैं, and I can say that waves are, या any wave is a function of what? Is a function of two parameters, that is the space and time. Space means the coordinate of that point. Okay. Any 2 points A and B in general can have the three coordinates x, y, z, and time can be represented by t. So waves are a function of, always any type of wave is a function of space or time. Space or time. Okay. That is what you are going to observe learn for electromagnetic waves also. The waves are a function of space and time. Okay. So that's what, and this is what I was defining. Wave motion is said to occur. पहले हमने information के respect में point किया. Now I'm just describing the behavior. See, you have seen the water body and the water waves generating throughout the water body. But ऐसा तो नहीं है. Did I hit the stone at each and every point जहाँ पे आप wave देख रहे हो? Did I hit the stone at each and every point where you are viewing, where you are seeing the waves? No, I have hit the stone only at one point, and that is the most important property of a wave. Disturbance at a one single point. Disturbance at a one single point is propagated throughout the medium. Disturbance at one point is propagated throughout the medium. Okay. Propagated throughout the medium. Now using this concept only slowly we will learn what are plane waves and uniform plane waves. Okay. Now moving forward, basic classification of waves भी आपको clear होना चाहिए. Basic classification of waves भी हमें clear होना चाहिए. So there are two types of ways to categorize wave. ठीक है. What is the first way? The first categorization, look into this, are longitudinal waves and transverse wave. What are longitudinal and what are transverse? ठीक है. Longitudinal मतलब, let me first define longitudinal, and I'll explain this with the diagram. It is a kind of wave in which the particles of the medium move in the direction parallel to the direction of wave, and transverse in which the particles of the medium move in a direction perpendicular to the direction in which the wave moves. Better to understand with a diagram. ठीक है. So just concentration, just look into this diagram. It's just an animation. It's just an animation rather. Longitudinal versus transverse. Longitudinal versus transverse. So look at this. This is a longitudinal wave in which the oscillations, if I talk about oscillations to be specific, oscillations or the motion of the particles are in the direction of wave motion. Okay, I'll hide myself also for a few moments. The oscillations, ठीक है, the oscillations, as you can see, oscillations किस direction में आप देख रहे हो? Okay. Let me stop here. Oscillations आप किस direction में देख रहे हो? You are seeing that the oscillations are horizontal in nature, and the wave. See, how is this phenomena created? मैंने क्या किया? Imagine a slinky, या imagine a spring, a slinky or a spring, जिसको आप, experiment क्या है इतना सा? experiment सिर्फ इतना सा है कि imagine a slinky or imagine a spring which you are holding from your two hands, ठीक है, and you give a horizontal push to it. ध्यान देना, what I am doing, you just give a horizontal push to that slinky or to that spring. What happens? Obviously, disturbance in the medium. मान लीजिए एक हैंड को फिक्स भी किया मैंने, imagine one hand is fixed, ठीक है, imagine one hand is fixed and just from the other hand I give a horizontal push to this slinky, to this spring. Waves are generated and again disturbance is only occurred at one point. Disturbance एक ही point पे हुआ. Wave motion मैंने कैसे describe किया? Disturbance as one point will propagate it throughout the medium. ठीक है. तो how is the oscillation seen? Oscillations भी horizontal है and wave is traveling where? Wave is traveling. I started the push from this my left hand and the wave will propagate towards my right hand and then back and forth. ठीक है. So this is the direction of propagation of wave and where is the oscillation? ठीक है. Even if you see the string, even if you see the particles of the string, it is also moving in the direction in which the wave is propagating. Is it getting clear? Is it getting clear? So that's basically a longitudinal wave. We'll take an example now. Okay. That's basically a longitudinal wave. For example, yeah, Harsha, that's very correct. Sound waves are horizontal. See this drum generating the sound. Okay. See this drum generating the sound. The particles push each other. The particles interact with each other in the horizontal manner before reaching what? This is what? I'll just stop it for a moment. This is a drum and this is, imagine your ear. Okay. So the sound waves before reaching to the ear, obviously they are traveling from the drum to the ear in this direction and the particles interact with them pushing each other horizontally before reaching the ear. The oscillations, the interaction of the particles is in the same direction in which the wave is propagating. Such waves, students, are known as longitudinal waves. And then, moving little forward. Now next example. Imagine that same slinky. मैं पिछली बार क्या बोल रहा था? Now focus on me. Imagine that same slinky. Last time what I've done, I hold that slinky from both of my hands. दोनों hands से hold किया and gave it a horizontal push. Now imagine both the hands, yeah, even if you want you can fix one hand, you give a vertical jerk to that slinky. एक तरफ से आपने vertical jerk दिया. What happens due to that vertical jerk? देखिए इस diagram में. By one hand or by both hands? See, so means your hands, जो आपका जो source है, that is moving vertically, because of which the oscillations now not in the wave motion. Now the oscillations are no more in the wave motion direction. See, oscillations are seen to be where? Oscillations are seen in vertical. Rather than defining x, y, z, मैं केवल vertical, horizontal बोलता हूँ. Here the oscillations are vertical, but the wave is propagating from my left hand towards the right hand. From my left hand towards the right hand, and wave is moving. The wave is propagating horizontally. And the oscillations are seen in the vertical direction. And such waves, my dear students, are known as transverse waves. So this was again, I repeat this, this was longitudinal. Horizontal push of the hand is longitudinal. Vertical push by the hand is transverse. They vibrate at 90 degree. This is the direction of oscillation and this is the direction of wave propagation. Okay. Yeah, Subramanyam, we are actually going to consider many such examples because we are going to actually go to electromagnetic waves, okay, which are commonly transverse in nature. And how they are transverse, what is TEM mode, that I am going to discuss also. Transverse electromagnetic waves. Transverse electromagnetic modes. Yeah, Harsha, light waves are transverse because light waves are examples of electromagnetic waves. Light rays are examples of electromagnetic rays. So that's why generally electromagnetic waves are transverse in nature. Both the electric and magnetic fields, we will prove this. What I am telling is, we will prove this, that both the electric and magnetic field, okay, I'll come back to the screen now. Both the electric and magnetic field of electromagnetic waves are perpendicular to the direction in which the wave propagates. Okay, so we will prove all these things. Okay, everything should have a sound derivation. Now, the other classification. The other classification of waves is electromagnetic versus mechanical. Electromagnetic versus mechanical. Now, what are mechanical waves? What are mechanical waves? Right. This case, when I have spoken about water waves कहाँ देख सकते हो? Only in a water body, ना? Where can you see water waves? In a water body, obviously. ठीक है. So such waves are known as mechanical waves, which require a medium for propagation. See, let's first see mechanical wave is a wave that is not capable of transmitting its energy through a vacuum, which cannot propagate through a vacuum. Mechanical waves require medium in order to transport their energy from one point to the another. They are mechanical waves. Whereas, what are EM waves? What are electromagnetic waves? They are those waves which do not require any material medium for transmission. They are just produced by the vibration of charged particle, and they have the ability to travel through vacuum as well. Okay. Now, what about sound waves? Whether they are electromagnetic or mechanical? See, our concern will not be sound waves. Our concern will be mostly on EM waves. But what about sine waves? Oh, sorry. What about sound waves? Can you say? Yeah, Subramaniam. Yes. What about sound waves? Are they mechanical or EM in nature? See, these are basic classification which you must have idea. Sometimes in the factual question which do come up in ESE, such basic basic simple definitions also they ask, simple criteria they ask. Sound waves are actually mechanical. Yes, Zayan, Abhiram, they are actually mechanical in nature. Sound waves cannot propagate in vacuum. They can propagate in air. See, air is not a perfect vacuum. ठीक है, एयर इज नॉट अ परफेक्ट वैक्यूम. आप ये मत सोचो कि आप बोल रहे हो और फ्री स्पेस में जा रहा है. सी, दिस इज नॉट टोटली अ फ्री स्पेस. दिस इज नॉट परफेक्टली अ वैक्यूम. एयर do have particles. Air also do have particles, and sound waves propagate through that particles. ऐसा मान लीजिए. Sound waves can propagate through the particles of the air. ठीक है, तो sound waves do not propagate in vacuum. एयर में कर सकते हैं, but air is not perfectly a vacuum. अगर perfect vacuum में जाओगे sound नहीं होगा. Inside a perfect vacuum, sound cannot be heard. Inside a perfect vacuum, sound cannot be heard. The sound wave is a mechanical wave. Chali. Okay, so these are some basic classification which you must know for the मैं बोल रहा हूँ factual question point of view. ठीक है, regarding EM में all the details, all derivations, why it is transverse, वो सब हम clear करने वाले हैं anyways with the derivation. Now, what is the concept of, these are just basic idea about waves. What is the concept of a plane wave? What is the concept of a plane wave? For this, my dear student, just look at one diagram. Again, take for example water waves. Take for example water wave and understand this diagram. Just concentration here. Take it. Just concentration here. Water waves. Again, imagine this is a stationary water body on screen. This is a stationary water body, and at a point I hit a stone. At a point I hit a stone. Already we have discussed what will happen. Waves will start generating, which are circular in nature. Right? Which are circular in nature. What happens as you go away from the source? Just keep on listening me, concentration here. What happens when you go away from the source? The radius of the circle increases, right? The radius of the circle increases. What will keep on happening? Yeah, ठीक है. Do not mind the exact shape of the diagrams right now. My whiteboard नहीं है, तो थोड़ा सा ये pen tablet में getting this accuracy is little difficult. Yeah, but what will keep happening? As you move away from the source, the radius of the circle keeps on increasing, right? इतना तो हम observe कर सकते हैं. So the further I go, the radius will keep on increasing. The further you go, the radius will increase. The more further you go, the radius will increase. और far जाएंगे, the radius is further increased. Let me go more far away, the radius keeps on increasing. Right? So that is a common phenomena. When you observe the wave at a large distance, the radius is increasing, and at a certain distance, at a certain distance, what happens? Now understand the important point. Ultimately, it's a circular wave front only. ठीक है, मतलब जो it's a circular wave only. But what is your sight of vision right now? आप ये देखिए, what is your sight of vision? Only your mobile or your laptop screen where I'm presenting this video. You are only able to view that. So actually there are circles only and the radius of the circle is increasing. बढ़ता जा रहा है. And what happens at a particular point, at a particular distance, the radius for you is that large such that this portion here seen for you. What does this portion represent? The last line which I have sketched. It will be looking just like a straight line. It will be looking just like a straight line. It will be looking just like a straight line. Right, everyone? Right, my dear students? So, when you observe circles at a large distance, you are only able to see a section of the circle. And because of that section of the circle, you see that circle as a straight line. वो है नहीं straight line, वो है circle. But you are able to view it. Your vision makes it a straight line. Then what happens in 3D? That was a 2D version. To make the diagram, I first took a 2D version. Now imagine a point charge. Imagine a point source located here transmitting the information. Now when I have a point source, any transmitter, जैसे FM transmitter अगर आपको देखा है, ठीक है? If you are listening to a FM transmitter, and suppose this is one FM transmitter, just imagine hypothetically this is a FM station and this is a transmitter. In which direction you should stand to hear the signal, to catch the signal propagated by the transmitter? You can catch it in all four directions, na? All four directions, upwards, downwards, everywhere. Okay. That means whenever energy is being transmitted, information is transmitted by a point source, by a transmitter, it is transmitted in all four directions. And what is the meaning of all four directions? मतलब in a spherical form. एक point के चारों तरफ सारे point लोगे तो what will you get? You will get a sphere, na? You will get a sphere. Okay. So when information is being transmitted by a point source, it should be spherical in nature. मतलब it is transmitted in all four directions. चारों तरफ, ऊपर, नीचे, आगे, पीछे. So it is spherical in nature. ठीक है? Something of this form. Something of this form. ठीक है? Something of this form. Like, suppose this is the point source which is transmitting the information. It will be transmitting in all particular direction. And then I've cut a piece of this sphere and trying to imagine this piece of the sphere when the radius of the sphere increases. Obviously, same phenomena hoga na. The more you move away from the source, the radius will keep on increasing. The radius will keep on increasing. And as the radius keeps on increasing, as the radius keeps on increasing, actually it is a spherical wave front. But जब sphere का radius इतना large हो जाएगा, what will you see at large distance? What will you see at large distance? The sphere, like circle is appeared as a straight line, sphere will be seen as plane, as a plane. ठीक है? So my dear students, what is the concept of a plane wave? What is the concept of plane wave? See, it's not actually a plane wave. It's a spherical wave propagated by a point source in all directions. Okay, in all spherical direction. Okay. But when I observe that sphere at a large distance, it is going to just appear as a single section. Something like this, as a plane. Okay, as a flat body. So हमने water wave से 2D version समझा. This is the 3D version. The sphere appears as plane at large distance. So my dear students, final point. What is a plane wave? It is just a wave, a spherical wave observed at a large distance. A spherical wave observed at a large distance appears to be a plane wave. Right? Appears to be a plane wave. A spherical wave observed at a large distance appears as a plane wave. Is this fine? Appears as a plane wave. Yes. Then moving forward, what is a uniform plane wave? Now finally defining the uniform plane wave. We have defined a plane wave. Uniform plane wave. First let's read the definition, then I'll explain this. It is defined as a wave whose value remains constant throughout a plane which is transverse. Transverse matlab perpendicular to the direction of propagation of wave. Direction of propagation of wave. To explain this, let me assume that a wave is propagating. A wave is propagating in z direction. A wave is propagating in the z direction. Okay. Now, what is a plane which can be perpendicular to z direction? Again, you can see we can define vectors में हम लोग ये repeatedly discuss करते हैं. Suppose this is the x-axis and suppose this is the y-axis. ठीक है. Suppose this is the x-axis and this is the y-axis. Suppose this is x and this is y-axis. So where will be z? X cross y. This is x cross y. Cross the height. Height I've taken as y. This is z. ठीक है. तो suppose this is x-axis and this is y-axis. तो x क्रॉस y is z. मतलब from my point of view जो conventions मैं ले रहा हूं, this particular direction which I'm pointing towards you is the z direction. Is the z direction, right? So suppose that a wave traveling in this direction. Suppose that a wave is traveling in this direction, right? Yeah, Subramanyam, we will learn. See, right now I'm talking general about uniform plane wave. When we discuss EM waves, we will say that जैसे मैंने value word use किया. Yeah, so by value I mean the value of E and H fields. By value I mean the value of E and H fields that we'll discuss. Okay, what is the electric and magnetic field associated with the electromagnetic wave, right? So by value I mean the value of E and H fields. Fine. Okay, so that we will see with time. Don't worry, we'll come back to all concepts. Yeah, so let me come back to this concept. A wave is propagating in the z direction. Okay, this is x-axis, this is y-axis. So this is what? This is a xy plane. Okay, suppose again let me take my tab. This is the xy plane, and what is the z direction? This is the z direction. Perpendicular to this xy plane is the z direction. Okay, now मैं क्या बोल रहा हूँ? This is what plane? This dimension is x. This dimension is y. So what is a plane? Okay, let me write down. What is a plane which is perpendicular to the wave direction? Wave direction is z. So what is a plane which is perpendicular to the z direction? That plane is actually xy plane. That plane is actually xy plane, right? That plane is actually xy plane. Now मैं क्या बोल रहा हूँ? A uniform plane wave is defined as a wave whose value, मतलब whose value of electric and magnetic fields will remain constant throughout a plane, that is the xy plane, which is perpendicular to the direction of propagation, which I've assumed as z of the wave. Okay. That means in the xy plane or any plane parallel to the xy plane, electric field and the magnetic field of the uniform plane wave, if it is uniform, I will call it as UPW, should be fixed, whose value remains constant throughout a plane which is perpendicular to the direction of wave. Now this is going to be very important result in the upcoming derivation. ठीक है, just remember अगर wave z direction में जा रहा है तो what is the plane perpendicular to z is xy plane, and the value of the wave should be constant throughout any plane which is perpendicular to direction of propagation of wave, right? So in xy plane, electric and magnetic field of UPW should be constant. Fine. That means electric field should be a function of, see, मैंने क्या बोला था? Waves are a function of what? Waves are a function of space and time, and space means x, y, z, and time means t. So generally wave value is a function of space and time, but in the xy plane the value should be constant. मतलब it should not depend on x and y. It should not depend on x and y. ये यहां से हटा देना चाहिए, ठीक है? Because in the throughout xy plane x और y की वैल्यू तो चेंज होती रहेगी, but wave value should not change. That means the wave value should be independent of the xy. The wave value should be independent of the xy. That means electric field should only be a function of z and t. Z matlab the direction in which the wave propagates. Here I have taken example z. If the wave is propagating in x direction, so here x will come. If it is propagating in y direction, so here y will come accordingly. Time to anyways will be there. Any wave is a function of time and space. But what parameter of space? Only that direction of space in which the wave propagates. Okay. The electric field or magnetic field will be a function of only z and t. Agar wave z mein propagate kar rahi hai. Fine. That is the uniform plane wave. Is that clear to everyone? That is basically a uniform plane wave. Okay. E as well as H also, both. H should also be a function of Z and T. Yes? Yes, dear students. Fine. So let's move towards the next concept. मैं क्या कर रहा हूं अभी पूरा overview spread कर रहा हूं आपके सामने. Before I start taking Maxwell equation and derive the actual wave equations, whatever basics is required, मैं आपके सामने just spreading out all the basic concepts. ठीक है? So before we go towards Maxwell and start deriving, you must be familiar with the phasor conversions. Phasor quantities क्या है and how to convert a time varying quantity into a phasor quantity. ठीक है? And dear students, if you are attending the session seriously, so I have told you repeatedly in the previous YouTube class also, जो लोग concentration से समझ रहे हैं, concentration से मेरा ये मतलब नहीं है कि केवल आप लेक्चर को देख रहे हो या व्यू कर रहे हो. If you are able to concentrate, if you are able to understand, please put your attendance. And how will you put the attendance? By hitting the like button of YouTube. ठीक है? So that will be the number of concentrating students and listening this video. Yes, Nasir pe we are going to do. See, it's not only one session on plane waves. We have continuous sessions. So I will cover the whole derivation of plane waves in this series. Don't worry. ठीक है, whole derivation will be covered. ना Banerjee, z equal to 0. See, मैंने क्या बोला? XY plane. I'll make this clear. XY plane is defined as z equal to 0. ठीक है. But if this is XY plane, understand everyone. If this is XY plane, any plane parallel to this will also have z value constant, na? So, and it will also be perpendicular to this. See, this is z, this is XY plane. Okay. If I take a plane parallel to XY plane, that will also be perpendicular to Z. So XY plane or any plane parallel to XY plane. Any plane parallel to XY plane will have the equation Z equal to constant. So it's not necessary Z equal to 0. It's not necessary that Z equal to 0. Fine. Yeah. Now, what is a phasor quantity? Okay, what is a phasor quantity? Phasor quantities are just complex numbers which will be representing a sinusoidal function. Matlab basically we use phasor to represent sinusoids. Functions of the form sin omega t plus theta or cos omega t plus theta, whose amplitude, angular velocity omega and initial phase are time invariant. The very important point is phasors are complex number, and every complex number basically has two parts: magnitude and phase. Okay. And phasor is a time invariant quantity. Okay. So say for example, how will I make the conversion happen? How do I convert a time varying quantity into a phasor? अब मैं ये topic क्यों cover कर रहा हूँ? Because the derivation of wave equation becomes pretty simple if I take the phasor forms of electric and magnetic field. You know, बहुत ही easily wave equation derive हो जाता है by using the phasor form. ठीक है. So first we will convert time varying into phasor, and later on we also learn to convert phasor into time varying. ठीक है, to ease out the process. So suppose this is the electric field. E equal to E naught cos omega t plus xi. ठीक है. This overall phase, what is the overall theta? If I talk about overall theta inside cos, that is nothing but cos omega t plus xi. This part of the phase is time dependent, and this is independent of time. This is independent of time, right? So theta is equal to omega t plus xi, where omega t part of the phase is time dependent and xi is independent of time. और जैसा कि मैंने बोला, phasor is a complex number, मतलब magnitude and phase, which is time invariant, which is time independent. ठीक है? That means how to convert it. The phasor of E is written as Es, and it is obtained by dropping real and suppressing e power j omega t. So now let me make this calculation clear to you. Okay, just follow with me. E equal to E naught cos omega t plus xi is given to you. Okay. Rohit, digital kahan pe? Where you want to, which platform you are referring to the digital? E equal to E naught cos omega t plus xi. Now I can write this as E naught real part of C. सबसे पहले मैं क्या करता हूं? I write it as a complex number because I want to get a phasor which is a complex quantity. Cos omega t plus xi plus j sin omega t plus xi. Right? Let me write it like this. Okay. Cos theta plus j sin theta. And when you take the real part of this x plus jy, what is the real part? This one, x. Real part matlab x. Okay. So ultimately when you take the real part, you will get cos only. So you will get this expression only, right? You will get this expression only. E then is equal to E naught into real part of, what is cos theta plus j sin theta? Euler's identity. Cos theta plus j sin theta is e power j theta. So I will write it as e raised to the power j theta. Matlab omega t plus xi. Keep on understanding. Then I will write it as, okay, I will hide the vision for a time. I will continue here. Okay, then I will write it as E naught real part of e raised to the power j omega t e raised to the power j xi. First continue with the derivation with me. Okay, now this is equal to E naught. मैंने क्या बोला? I want a complex quantity which will only contain what? Which will only contain the time invariant phase. Which will only contain the time invariant phase, and that is why the method is written here. It is obtained by dropping the real part and suppressing the e power j omega t. Okay, so just suppress the term, just suppress the real part, and then you obtain the phasor form of electric field, and this phasor form of electric field will be known as Es, and it is just written as E naught e power j omega t. E naught e power j, sorry, I'm sorry, I told to suppress the e power j omega t. So I will suppress e power j omega t and I will drop the real part and I'll get E naught e raised to the power j xi. This is known as the phasor form. Now, please avoid any confusions. Please avoid any confusions. Okay. This is not actually the expression of electric field. Okay. This is not actually the expression of electric field, but it's a way to represent electric field in phasor form. Later on, ठीक है, मैंने क्यों बोला इसको क्यों यूज करेंगे? Because it will be helpful in derivation. ठीक है, we will first derive the quantities in phasor and later on we will convert the phasor into time varying. So my dear students, how will I convert vice versa? How will I convert vice versa? A phasor into time varying. ठीक है, how will I convert vice versa? ठीक है, yeah, I will come back to this fact later on. How will you convert a phasor into a time varying quantity? Reverse. ठीक है, suppose the phasor is given to you as E naught e raised to the power j xi. What you have to do to obtain the actual electric field answer? To obtain the actual electric field answer, multiply Es by e power j omega t. Whatever terms जो हमने drop किए थे उनको reintroduce करेंगे e power j omega t and take the real part. ठीक है. Then this will be E equal to real part of Es, which is E naught e power j omega xi e power j omega t. This will be equal to real part of E naught e raised to the power j omega t plus xi. And what is the real part of e power j theta? You will obtain it as cos theta, cos omega t plus xi. Same expression from where I started. ठीक है, so that is the reverse procedure. Multiply by whatever terms we had suppressed. And why we have suppressed? See Sangeeta, why we have suppressed? ठीक है, why we have suppressed, just see, I'll repeat this particular form which I've written here. That's not exactly the actual electric field expression, because actually the electric field will depend on time. Every wave will be a function of time. But for the time being, मैं एक ऐसा alternative representation लिख रहा हूं. We all know time factor तो होगा ही, but for the time being एक ऐसा representation मैं present कर रहा हूं, so that, ठीक है, we only express the electric field as a magnitude and the phase which is time independent. So that these types of expression, you will see, you will understand, wait for the some time, this will be very, very easy to forward in derivation. इससे derivation simple हो जाएगा. ठीक है, तो first we will obtain the phasor form of ES, and once you get ES, how to get back actually, ठीक है, just multiply by e power j omega t and then take the real part. Multiply the phasor by j omega t and take the real part of the product. Take the real part of the product. That's how we can move forward, right? So that's a highlight of conversion of time varying to phasor and phasor to time varying, and also one result I've mentioned, nothing. See, इसी electric field को, look at this expression. When you differentiate with time, what will happen? Just if I look at this expression only, and when you differentiate this expression with time, when you take del by del t, see, e power x has the differentiation e power j x. Only thing, a term j omega will be multiplied by the chain rule. A term j omega will be multiplied. So that is why, take the direct result. If the E has the phasor, if electric field E has the phasor ES, then the phasor of del E by del T will be j omega ES. It's a simple mathematical conclusion. The phasor of del E by del T will be j omega ES. Fine. Okay. Rest all will be same. E power x ka differentiation e power x. By differentiating with time, by the chain rule, see what is the coefficient of time? J omega. That will be multiplied separately. Okay. So just follow this result. Just remember this result, that the phasor will be multiplied by j omega if you differentiate E with respect to time. Okay. Now, moving forward. In one dimension, the wave equation takes this form. Okay. I will just make it very clear to you that how this has come. Derivation of this whole thing in the next session, in the next class. Derivations I'll be able to begin in the next class, but right now let me complete some important properties regarding wave. Okay. So that when I start the derivation, you know the basics and properties and important formula. Okay. So the derivation of this will come up in the next class. Let me make this very clear to you. Okay. This is the one dimension wave equation in free space. Okay. This is actually the one dimension wave equation in free space. Yeah, Zion, this is very similar to the Fourier differentiation rule. It's good to remember like that. It's similar to the Fourier differentiation rule. Okay. The Fourier transform of x dash t is j multiplied by j omega x omega. Okay. So within the free space, the 1D wave equation take this form, whose derivation will be considered next. Del 2 e by del t square minus u square del 2 e by del z square equal to 0. Okay. Where u is the wave velocity. Okay. Yeah, Deepa, next class means the next EMT class itself, not the target batch class. Next class matlab next EMT session, when we continue with plane waves, I will derive the wave equation. Okay. And its solution. This will also be derived. Everything will be derived. Right now, just to extract the property, केवल देखते चलिए. This will also be derived in next class only. Every derivation in next class. The solution of this function is given by any function of the form z minus ut or z plus ut. First of all, let's convert this equation in phasor form, the equation 1 in phasor form. Okay. How to convert in phasor form? See, if E has the phasor ES, what will be the phasor for differentiation? Double differentiation with time hai ye. Double differentiation with time. So 2 times j omega aa jayega. So j omega into j omega, that is j omega square into ES. minus u square. This is differentiation with z. यहां प्रॉपर्टी अप्लाई नहीं होगा, तो del 2 es by del z square converting into scalar equal to 0. ठीक है, j स्क्वायर का वैल्यू -1. ठीक है, तो माइनस एंड माइनस हम कैंसिल करके फाइनल इक्वेशन लिखते हैं, u स्क्वायर del 2 e by del z स्क्वायर प्लस ओमेगा स्क्वायर es इक्वल टू 0 डिवाइड बाय u. नेक्स्ट यहां पे क्या किया है, I've just divide the whole equation by u square. ठीक है, so when you divide by u square, here you get the quantity del 2 es by del z square plus here you should be actually getting a quantity omega square divided by u square es equal to 0, which I have replaced at beta square. Okay, ठीक है. Yeah, what's the name, Manish, I will consider something about mediums and waves. स्केलर मैं क्यों बोल रहा हूं, और होमोजीनियस मीडियम की बात भी करेंगे. ठीक है, व्हाट आर आइसोट्रोपिक मीडियम, व्हेन आई स्टार्ट द डेरिवेशन आई विल कवर अप. ठीक है, तो जो डाउट डेरिवेशन के लिए है मैं उसको अभी इग्नोर कर रहा हूं, तो वेट फॉर द नेक्स्ट क्लास सो दैट वी गेट द मोर डिटेल्स. सो दैट मीन्स हियर बीटा इज रेफरिंग टू व्हाट, बीटा इज ओमेगा बाय यू, एंड बीटा इज एक्चुअली नोन एज beta is actually known as phase constant of the wave. Why so? I will explain it later on. ठीक है, beta is the phase constant. We will also get a term alpha, that is known as the attenuation constant. That is not in the picture right now. ठीक है, so what is the importance of beta, that we will explain, that we will understand automatically with the derivation. So beta will represent the phase constant given by the basic formula omega by u. ठीक है, now जैसा कि मैं बोल रहा हूं, the solution of this equation will be in the form of z minus ud or z plus ut. So let's take one example. Suppose that E has the form a sin omega t minus beta z. मैंने क्या बोला, wave equation, that differential equation लिखा, that also we will derive. How we will derive? Using the Maxwell equation, and we will solve that differential equation to get this answer ki how the electric field is sinusoidal in nature, sin omega t minus beta z or cos omega t minus beta z. ठीक है, so right now I am just beginning the discussion from here. A sin omega t minus beta z, A is the amplitude, omega t minus beta z is the phase. Everyone know omega is known as the angular frequency, beta is known as the phase constant. Why it is phase constant, that we will cover up later on in the very next session itself. Okay, now some important parameters जिसके लिए मैं ये discussion ले रहा हूं. Ultimately it's a sine waveform, it's a sine theta waveform which is dependent on two parameters, and wave is always a function of space and time, na? So let's sketch it one by one with respect to one variable. So suppose if I have a plot of E with respect to z, t is constant, but ultimately it is a sine theta function. Which will be periodic. Every sine theta waveform will be periodic. So when I take a plot of electric field with respect to z, it will be a periodic waveform. And what is the meaning of periodicity? The value will keep on repeating. After a certain distance. See, this point and this point are identical, and the nature of the wave repeats after this. ठीक है, I defined this parameter as lambda. ठीक है, the wave takes the distance lambda to repeat itself, for the value to be repeated, and this distance of repetition is known as the wavelength. I hope you are aware about this. ठीक है, but we'll be using these parameters very often. So why I am introducing this? Wavelength, distance traveled by the wave to repeat itself. Distance traveled by the wave before it repeats itself is the wavelength. ठीक है, and similarly, just keep following. When I take a plot with respect to t, z is constant. Ultimately, है तो sin theta function which is again going to be periodic. ठीक है, don't worry कि exact waveform थोड़ा ऊपर नीचे हो सकता है, but I've just taken a sinusoidal waveform. To be fast, randomly, see, whether it starts from 0 or it might be little shifted, but sin theta periodic to hoga. Main point kya focus kar rahe hain? It will be periodic, and because it is periodic, its value will repeat, and this time we are taking it as a function of time. So what I will say that the value of the wave repeats after every fixed time, and that time is known as what? The time period. The wave takes the time t to repeat itself, and then this is known as the time period. This is known as the time period. The time taken by the wave to repeat itself is the time period. Okay. So suppose if I call this point as P and this point as Q, going to the previous waveform, again this point is Pu and this point is Q. What is the distance between PQ? What is the distance between PQ? Simply apply the formula. Distance is given by speed into time. Okay. Distance of PQ is lambda. Distance matlab distance of repetition equal to speed of the wave is taken as u, and the time taken for repetition is t. So you get the very fundamental formula for lambda as well. That is u into t. Okay. But we also know that t can be written as 1 upon frequency, because frequency is 1 upon time period. So lambda can be written as u by f. Lambda can be written as u by f. Okay. So lambda is u into t or u by f. That's u by f. No, Subramanyam, why the direction will be constant? Wave is propagating in the z direction. If the wave is propagating in the z direction, so obviously z की value बढ़ती जा रही है ना when it moves, when it advances. Imagine it is traveling from z equal to 0 to z equal to infinity. So why z is a constant? Why z is a constant? Okay, so these are the some basic relations between time period, wavelength, frequency, which everyone must know. Also one more formula for beta coming up. One more formula for beta. Beta is omega by u. I have referred here in the previous discussions. Beta is omega by u. Beta is omega by u. And I can substitute the value of omega. Omega is 2 pi by t. So 2 pi by tu, and the value of tu is lambda. So beta has one more formula. Beta has one more formula, that is given by 2 pi by lambda. 2 pi by lambda. Okay. Harsha, it will be 3 into 10 power 8 if it's traveling in free space. 3 into 10 power 8 if it's traveling in free space. Or ek aur cheez. Students, listen. Everyone knows that the speed of light, speed of EM wave traveling in free space is 3 into 10 power 8. Okay. Wanna know why it is 3 into 10 power 8? If you want to know why it is 3 into 10 power 8, ये answer भी next class में clear हो जाएगा. So this is why this is 3 into 10 power 8. That will also be pretty much clear within that next class itself. Okay. So when I did derivation, when I say derivation, it is the complete details about, when it is complete details about the waves, even the speed, why the speed is 3 into 10 power 8. Okay, so we will drive this fact also. Okay, Harsha, so it's 3 into 10 power 8 in free space. If it's any other medium, it will be less than 3 into 10 power 8. Okay. Chaliye. So beta is omega by u, that is 2 pi by lambda. Now, what is the function I'm taking? I've already told you, let's assume that this is the function. This is the function E equal to A sine omega t minus beta z. Okay. Now, A sine omega t minus beta z. Now, let's take the various expressions at different values of time. Understand, very simple sinusoidal calculation. If t is equal to 0, what will be E? It will be A sine, t ki jagah 0, so A sine minus beta z, and sine minus theta is minus sine theta. Sine minus theta is minus sine theta. Okay. Now, at t equal to t by 4. Okay, I'll hide my view. At t equal to t by 4, what will be electric field? It will be given by A sine of omega t, t ki jagah, omega ki jagah let me write as 2 pi by t, and then t is t by 4. minus beta z. See, this is cancelled. T cancel, it is pi by 2. Sine 90 minus theta is cos theta. So this becomes a cos beta z. Okay. And then if t is equal to capital T by 2, E will be equal to a sine 2 pi by t into t by 2 minus beta z. T and t cancel, 2 cancel it. Sine 180 minus theta, which is plus sine theta, second quadrant. Sine 180 minus theta is sine theta. Okay. So when I advance the value of time, when I increase the value of time, what is the relation of electric field with respect to z? मैं ये highlight कर रहा हूँ. Okay. So everyone now knows the waveform of sine theta. यहां पे हम exact waveform sketching की बात करेंगे. This is just the waveform for sine theta. Okay, it will start from origin only because sine 0 का value 0 है. So what should be the waveform for minus sine theta? ये भी हमें पता है. When I talk about cos theta, the cos theta waveform will start from 1 because cos 0 is 1. This will be cos theta waveform. So each of these waveforms are known to me, right? Will be known to me. So look at this. The first one, t equal to 0, where the electric field was minus a sine beta z. So minus sine theta. Because of minus sine theta, I have inverted this waveform. At t equal to, this one, at t equal to t by 4, the waveform that we derived was a cos beta z. Just keep following with me. And at t equal to t by 2, E will be equal to a sine beta z. So this is perfectly sine beta z. Okay, this is cos waveform and this is minus sine theta waveform inverted with respect to y-axis. Yes, Manish. It will be little decreased. Minus a sine beta z. Okay. So let's see with respect to the first wave and fix any point P. Let's pick up this peak point, this maxima point. When I see the same maxima point in the next wave, where has it displaced? कहाँ displaced हुआ है वो? It has been displaced in the right direction with respect to Z. And when I look at the same point P in the next waveform, it has displaced more towards the right. It has been displaced more towards the right. That means what? One important point to be noted that comparing any one point. Similarly, we can take the other points also, like ये minima भी compare कर सकते हैं. But what is the conclusion that I am getting? That this wave is propagating in which direction? Whether it is plus z or minus z. ये तो मैंने starting में ही बोल दिया था कि let's assume wave is propagating in z direction. वो मैंने beginning में बोला था. But in which direction? Positive or negative? That wave is propagating in the plus z direction. And this simple point you must remember, that whenever you are given, whether it is sine or cos, if it is a function of the form omega t minus beta z, wave is propagating in plus z direction. And if it is a reverse, omega t plus beta z, similarly we can sketch the waveforms and analyze. It will be traveling in the minus z direction. So z में travel कर रहा है, ये तो clear है, but whether it's positive z or negative z, that's the thing that I was trying to discuss. And looking into this point P, it's clear that the wave is, all the points of the wave are moving forward in the positive z direction. Fine. चलिए. So minus omega t minus beta z मतलब wave traveling in plus z direction. Omega t plus beta z, wave is traveling in the negative z direction. Okay. Now one more point. The uniform plane wave actually follows the TEM mode of propagation. That is, TEM stands for transverse electromagnetic mode. In which both the electric and magnetic fields will be perpendicular to the direction of propagation of wave. That means ठीक है, let AE be the unit vector. ठीक है, this we will prove, this will automatically follow in the next class. Proofs will follow in the next sessions for this. Let AE represent the unit vector along the electric field direction. Let AH represent the unit vector along H direction, and let AK represent the unit vector along direction of wave propagation. Along the direction of wave propagation. Okay, along the direction of wave propagation. Okay. And this TEM mode means both the electric and magnetic fields will be perpendicular, and rather it turns out that AE, AH and AK are mutually perpendicular to each other, similar to the AX AY AZ rule. AX AY AZ rule. ठीक है, तो vectors में I have told you how to remember the relations between AX AY AZ. Same you can apply to AE, AH, AK. Same you can apply to AE, AH and AK. Okay, so move in the cyclic anti-clockwise manner. ठीक है, वेक्टर्स में आपको ध्यान होगा, आई हैव टोल्ड द साइक्लिक एंटी क्लॉकवाइज रूल फॉर एक्स वाई जेड. सेम आई एम अप्लाइंग हियर. ठीक है, so AE to AH, what is the direction missing? AK. H to K, so what is missing here? E. K to E, so what is missing? AH. Write down the missing variable on the line. So what is AE cross AH is equal to AK. ठीक है, then what is AH cross AK is equal to AE, and what is AK cross AE, that will be equal to AH. Similar to XYZ, you can remember this cyclic anti-clockwise pattern once again. That cyclic anti-clockwise pattern can be remembered. Very similar to that. Fine. Okay. ठीक है, तो dear students, I'm going to towards a question now, and before that let me remind you, if you're interested in the Target Gate 21 batch, this is the procedure to enroll. You can go to the buy now section, select your installment option and proceed to pay, get only 1,000 rupees to get the access till 15th. Man, right now engineering mathematics is going on that, where we have just completed the vector calculus, and tomorrow we are starting with the differential equations. Tomorrow's class is at 10 a.m. in that batch. Okay, and tomorrow 25th April is also the last day to enroll for the scholarship test, and which is going to be conducted on 11th of May. Okay, so on these basics, let's take some quick question. Yeah, let's first take this question. Let's first take this very, very basic question. It's actually a gate 1 mark question. I haven't mentioned here. It's a gate 1 mark simple question. Can you come on with the answer very fast? Come up with the answer fast. Very simple question. Yes, Shriram. Correct answer. Zayan, correct answer. Yes, Nasir pe, Haricharan. No, Nasir pe, please recheck. Your answer. Okay. So it's a very simple question. The electric field expression is given to be 10 cos of 2 pi 10 power 70 minus 0.1 pi z. Okay, yes, Deepa, correct answer. So compare it with the form of omega t minus beta z. Compare it with the form of omega t minus beta z. Okay. Now, if I compare it with the form of omega t minus beta z, what is beta? Beta is omega by u. Okay, beta is omega by u. Okay, so from here, what will be the value of u? U will be equal to omega divided by beta. So u will be equal to, what is omega? It's 2 pi into 10 power 7 divided by beta, which is 0.1 pi, and the answer is there on the screen. Pi and pi cancel, 0.1 upar jayega, so it becomes 10. So 2 into 10 power 8 meter per second. Option number B. Very simple. Very simple. Okay. Yeah, Subramaniam. Very simple answer here. Fine, dear students. Next question. Next question. 4 questions are actually followed here. 4 questions are coming up here. On the same data, they have put up 4 questions. Please follow everyone. Electric field in free space. They have mentioned electric field in free space is given by this expression. Can I have the first answer directly? Can I have the first answer directly? Can I have the first answer directly? E equal to 50 cos 10 power 8t plus beta x. Yeah, Zayan Sriram. Correct answer. Yes, Subramaniam, correct answer. Deepa, correct answer. Nasir, please recheck again. First answer C. It is of the form omega t plus beta x. Number one point to note that it is x. It is x. Matlab wave is traveling in the x direction. Now there is no z. Okay. Because the wave is a function of x, it might be traveling in x direction. But which x? Plus x or minus x? Because it is plus. Now because of this plus, I will conclude that the wave is propagating. I will call the propagation vector of wave as AK. I have already defined. Is minus AX. Option number B. Minus AX. Wave is traveling in the minus X direction. Okay. Now second, what is the direction of magnetic field? What is the direction of magnetic field? Okay. So for that, don't be confused. What is the rule that I have to follow? AE, AH, AK. Okay. And I need to find AH. I need to find AH. So just use this result to find AH. AH kahan pe aayega? AK cross AE line pe. So AK cross AE will give you the value of AH. Okay. What is AK? Direction of wave. That is minus X direction. Cross AE. Electric field is given. See, electric field component is given in which direction? Y direction. So AY. Okay. What is x cross y? Let's take minus outside. X cross y you all know is z. So the final answer is minus az. Minus az. D is the correct answer. Yes. D is the correct answer. Fine. Yes, Zayan, Deepa, Sriram given the correct answer. Suresh correct answer for second. Yes. Okay. Okay. So you have to actually follow K cross E. You have to actually follow AK cross AE, then you will get AH, and that is minus of AX cross AY. Okay, so minus alag kar denge, AX cross AY is AZ. So the final answer is AZ. Fine. Chiranjeev, I'm not able to understand your doubt clearly. Can you recommend? Can you please recommend? Now students, third answer. What is the value of beta? What is the value of beta? Beta is given by the formula omega by u. Omega by u. Okay. What is u? What is u? Here what is u? See, question mein saaf bola hai free space, and because they have mentioned free space, u will be equal to c. U will be equal to c. Okay, so what is beta? Will be omega by sp. That is 3 into 10 power 8 value. What is omega given? C. You can compare this. Omega is 10 power 8. So 10 raised to the power 8 divide by 3 into 10 raised to the power 8. Beta answer is 1 by 3. Beta answer is 1 by 3. Okay. Beta answer is 1 by 3. Fine. Yes, 1 by 3. Correct answer. Okay. That is option number C. Option number C. Very, very basic questions right now we are solving. Okay. Now, time taken by the wave to travel a distance of lambda by 2. Time taken by the wave to travel a distance of lambda by 2. Okay. So, what is the time taken? What is the time taken to travel? Okay, to travel a distance of lambda. See, lambda is the distance jitme repetition ho. And what is the time taken by the wave to repeat itself is t. Okay. So, what is the time taken for lambda by 2? It will be just t by 2. It will be just t by 2. So, find the value of t. What is t? T is given by the formula 2 pi by omega. T is given by the formula 2 pi by omega. Okay, so that is 2 pi divided by 10 raised to the power 8. Omega is 10 power 8. So this is 2 pi into 10 power minus 8. So what is the answer? Answer is actually t by 2. And when I take t by 2, it will be pi into 10 power minus 8. That is 3.14 into 10 power minus 8. Okay, so answers as in nanosecond. So we can convert in nanosecond. Okay. Yeah, we can convert it into the nanosecond. Okay. What will be nanosecond for this? 10 into 10 multiply kare to 31 divide by 10 will give you nanosecond. So 31.4 nanosecond. That is option B. That is option number B. Yes, Chiranjeevo, but right now first we are finding the wave direction which is minus x. Pehle wave direction nikala by looking into this sign. And then I commented on the magnetic field direction. So first you have to take the wave direction. Okay. Chiranjeev, correct your calculation once. Okay. That's a very basic question. Very basic question. And dear students, today I have just covered the very basic property and very basic formula regarding the wave and property of wave. Okay. कुछ चीजें हमने डायरेक्टली एज्यूम की एंड दैट वी विल ओपन अप द होल थियरी इन द नेक्स्ट क्लास. ठीक है. A very similar kind of question, you can take it for homework as well. A very similar question, like again 1, 2, 3, 4. Set of 4 questions are given here. Take it as homework and solve it like the previous question only. Solve it like the previous question. Only difference is in place of electric field, I've given you magnetic field. Okay. In place of electric field, I've given you magnetic field. Okay, so please take this as a homework. Please take this as the homework. Yeah, and my next class, next YouTube session, my next YouTube session for EMT in the startup series will be on Tuesday. As you know, I start from Tuesday, 8 p.m. where we have where we discuss the wave propagation in detail. Wave propagation and all derivations. Okay, so whatever we assume directly today will be, taken up with derivations in the upcoming class. So Tuesday, all important derivations will be covered. So that's a very important class, students, if you are following this series. Continuously. That's a very important discussions that we are going to have on the next YouTube session for EMT, Tuesday, 8 p.m. Okay, so please follow that and see you again on Tuesday, 8 p.m. And by that time, for those students who are following the target batch, tomorrow 10 a.m. I'll see you with the discussions of differential equations. Okay, so it's time for me to sign off. No, Abhiram, as of now in the series, not going for electrostats and magnetostats, directly going towards the Maxwell equation and wave propagation concepts. Okay, so with this I'll sign off, and you dear students, take care of yourself, keep studying hard. I'll see you tomorrow once again in the target gate batch, and the YouTube session, next session, Tuesday 8 p.m. Okay, this I'll sign off.